So yeah, welcome everyone. This is the CR Library workshop for collaborating and coordinating research projects while remote. So we do have the slides available. We can pop that link in the chat, and it's also on the screen here. It's bit.ly/remote-research-workshop 2021. And we're sharing the slides because there's a lot of links that you might find helpful for following up on, or if you want to kind of click away and follow any of those links while we're talking, you're welcome to access the slides. So I think on the next slide, before we get started, we just want to acknowledge that, we're living through multiple crises right now, and the pandemic and other structural inequalities have disproportionately affected people of color, particularly Black and Indigenous folks. So as members of the UCR community, we stand with Black Lives Matter against racial injustice, police brutality, and other human rights violations. And we also want to recognize our responsibility to the original and current caretakers of this land, water, and air, the Cahuilla, Tongva, Luiseño, and Serrano peoples, as well as their ancestors and descendants, past, present, and future. And while we're currently meeting in a digital space, we do invite you to learn whose ancestral lands you might be physically located on at the website on the screen. It's native-land.ca. So essentially, for today, thank you for joining us, and, feel free to engage in whatever way you're comfortable. And we're going to share our contact information. Feel free to ask questions in chat, but also follow up with us afterwards. So just do whatever makes sense for you. So I'll go ahead and introduce myself. I'm Rachel Starry. I'm the Digital Scholarship Librarian at UCR Library.
And I'm Janet Reyes, the Geospatial Information Librarian, and we are both in the Research Services Department. And when we're on campus, we'll be in Orbach Science Library.
Yes. So I believe, yes. So what we'll be talking about today, we actually have a lot of information to kind of cover, so we might go a little quickly. Definitely let us know in chat if you have questions about anything in particular that we talk about. But essentially, we're going to share some recommended tools and best practices for coordinating your research projects and managing kind of collaborative projects while we're still in this remote environment. And we'll look at tools and best practices kind of within these different areas: document and database collaboration, task and project trackers, citation management with a group, file sharing and version control, and then some cloud-based programming and dependency management tools. And again, the link to the slides is here, and I will pop that in the chat.
Great. So I'm going to start off. I'll cover the first three topics. And first, we're going to look at document and database collaboration. And the way we've set up these slides is that there's going to be a slide that gives an overview of a particular tool, and then another slide that talks a little bit about the benefits and limitations of that tool. Then we'll move on to the next topic, or the next tool rather. And then at the end of the section, there'll be a slide that has links for more information about that set of tools that we just talked about. And that will give you guys an opportunity to maybe, we'll pause a little bit and you could ask any questions either verbally or in the chat. You can also take the opportunity to talk about your experiences with the tools we just covered, or maybe you have tools that are comparable but different, and you might want to talk about your experience with those tools. So we welcome any kind of contributions like that you care to make. And we realize, Rachel and I do, that our categories here are a little bit mushy. They kind of mesh into each other sometimes. And also some of the tools cover more than one category that we're presenting. So we understand that. We just created this structure just to get kind of a handle in general on what some of these tools can do for you. So the first tool I'm going to talk about is Google Apps. And I think this is one that's probably familiar to most of us. And it was even a struggle to understand how to label this slide, because we're talking about Google Apps. They used to be called G Suite, and then Google changed the name to Workspace, but we're not talking about all the tools in Workspace at this point. So it's a little confusing, but basically what we're focusing on, the ones that you can use for document sharing. And you can see the bullet points listed on the right-hand side, the ones that particularly pertain to sharing documents. I was not familiar with Google Drawings, but that is like creating charts and diagrams and things, and you can do that collaboratively. And I was familiar with Google My Maps because that's kind of my area of interest in particular. But please understand that the other apps listed on the left-hand side, and then there's even more apps, many of those can help you with other aspects of conducting your research projects remotely. So yeah, just be aware of that. So for Google Apps, what are the benefits and limitations? And mostly I've looked at several reviews. It's not just my opinion. It's like what lots of other people are saying. I kind of cherry picked and the ones that seem to pop up the most from a set of reviews that I reviewed. So for benefits, people like speed, performance, reliability. We all know it's convenient and fairly easy to use. It's possible to track collaborative input, and it is possible to retrieve earlier document versions. However, it's not super smooth or easy, and it's not really a strong point of Google Apps. So I almost want to push that bullet point over to the limitations. In addition to mentioning that, especially like with Google Docs and Sheets, it's less advanced than what Microsoft Word and Excel can offer in terms of functionality. You do need to have internet access, of course, and that might be a concern if you have concerns about security due to its being in the cloud and everything. And lastly, the documentation can be unclear or hard to find. So if you have questions about how can I use this app to do something, and you try to look for documentation, it can be quite a search, and maybe the documentation when you get to it is not super clear to understand. And that one I agree with. I have tried that myself, and it's not always easy to figure it out. So the other tool that we're going to look at in this category is Airtable, and this is more on the database collaboration side of things. Airtable is a spreadsheet database hybrid. So it stores the relationships between the different data elements you have in there. And this means you can do lots of things, like you can view it in different formats, you can filter and query. You are able to attach documents, photos, and videos to your data points, say. So I read one use case where an editor for an online publication was communicating with the author of an article that they had submitted back and forth, all within Airtable, like trading editorial comments and things like that. So it's set up for that kind of collaboration on documents. Airtable provides dozens of templates for different use cases, which is really nice. You can scroll through and try to find the use case that matches your situation, and then you can just modify that slightly and go from there instead of having to start entirely from scratch. And like most of the tools I'm going to be talking about, there is a free version of Airtable and then a paid version where you get more functionality the more you are willing to pay. So of the tools I've reviewed for my sections, what I noticed was that Airtable had the most positive reviews from the users, and also the most enthusiastic positive reviews. So people who use Airtable, from what I saw, really seem to like it a lot. And what they like is the coding, color coding and the aesthetics. It's easy to edit. They like how customizable and scalable it is. And the fact that Airtable provides frequent updates, so they're continually trying to improve what they offer. The limitations are, well, it's not possible to perform math operations in a cell. So if you had a column of information that was all numerical, it's not possible to divide it by 2 or multiply by 50 or something like that. You can't do that within Airtable. It's possible to export, but it's not easy. And then this last bullet point probably doesn't apply to most of us. I think it's more for the companies that have like 100 or more employees or something. But some people felt that you really couldn't do much with Airtable unless you went for the premium version, and the premium version cost too much. But again, I don't think that really applies to us today. So here's that slide I mentioned where we have a summary of links so you can find out more information about the tools I just talked about. And it's your chance to ask questions either in the chat or verbally if you'd like, and then share your experiences with these tools, or mention maybe in the chat some other tools that you've tried that kind of do the same things as these, and your experiences with those. And then I'll move on to the next set of tools, which is task and project trackers. And I have two tools to show you here. So Trello is the first one, and that illustration there really shows you what Trello is. You can create cards and form them into lists and put them on a board, and that helps you organize and prioritize aspects of a project you're working on. You can attach due dates, so that allows you to plan and schedule. You can attach files and images, or also link to the cloud, to cloud storage. You can tag particular team members to the different tasks that are represented on the cards. You can automate portions of your workflow so that if you can set up rules so that if a card moves from one column to another as the project progresses, it will trigger certain things that the project manager doesn't have to think about. Trello will do it for them automatically, like notifying somebody, hey, this one is coming your way, or something like that. And again, it has free and paid versions. So benefits of Trello, people like the fact that there is two-factor authentication, even with the free version. So that's a nice measure of security that they provide. It has a really nice knowledge base, easy to find information, and it's extensive as well. And with the free version, you can choose one power up, or it's like a premium function that normally you'd have to pay for to get, but they allow each board in a free account to have one power up feature, which is kind of nice. And you can pick which one you want. And Airtable also has this, but you can add features to it through extensions. The limitations are, well, you saw what it looks like. That's it. I mean, it's great for what it is. It doesn't have a lot of more complex project management functions. And so for that, a lot of people just decide it's not really suited for large or complex projects. Now, the other tool to look out here is Basecamp. You see a screenshot on the left of the kind of things, the interface for Basecamp if you have a project going on. You can see in the bullet point, the first bullet point, all the things you can do with Basecamp. And it is possible to track multiple projects. The free version is called Basecamp Personal, and that allows for 3 projects and 20 users and a gigabyte of storage. So what are people saying about Basecamp? Well, they say it is well organized, and it also really helps communication both internally and externally. And one instance of that is that it integrates well with email. People who do creative projects in particular seem to like Basecamp. Like if you're, say, maybe working on a team to create a podcast or something like that, Basecamp seems to lend itself really well to that kind of a endeavor. Limitations, not so great for archiving or reporting. Conversations can get out of hand if there's lots of people involved. It's not the best tool probably for document collaboration. And there is no dashboard view for, say, the person who's the project manager. So I did see a little bit more grumpiness in the reviews for Basecamp than I did for Airtable, for instance. So I don't know if that's just what I saw, but and really, people like it just as well as Airtable, but yeah, that was just my impression. So again, here's that summary slide for more information. If you have accessed our slides, you'll be able to click these links and view some reviews and also some tutorials on how to get started with these tools. And here's a chance for you to put anything in the chat that you would like regarding these tools or similar tools, or to ask a question. And with that, I'm going to move on to my third and final category, which is citation management. And we recognize that there are several citation managers available to you. We are only going to talk about Zotero with this workshop. And that's because Zotero is open source and the library does primarily support open source tools. But we do recognize that you might be able to do similar things in, say, Paperpile or EndNote. But for Zotero Groups, what you can do is if you have a Zotero account, you're working with other people who also have a Zotero account, you can create a group. And with those other users, you can share your work and your sources. You can collaborate on research, so you can have a bunch of people looking for sources and put them in your Zotero library. And then there's other Zotero groups out there in the world, and if you find one with similar interests, if they've made their group public facing, then it's possible to see what resources they're using with their research. So that's pretty cool. The benefits of Zotero Groups, the first bullet point's probably the most important. There are 3 settings that you can use when you're setting it up. So it can be public, which means anyone can join it, and also anyone can see what's in there, or anyone can join and anyone can see it. There's a middle ground where it's public facing, so anybody can see it, but you can only join by invitation. And then there's private, where it's only visible by the people who are group members, and you can only join by invitation. You can set the editing levels for the members, and you can create an unlimited number of groups. The limitations are, well, the storage space depends on how much storage space the group's creator has. And it's not automatic for being able to see who added what, but you can set up a system where you can track that. So, yeah. And here's that summary slide. A couple links to a couple guides that talk a little bit more about the Zotero groups. And I see there was a question, but I didn't see what it was. Is this a good time to talk about that question?
We could. Yeah, the question was that someone would love to hear more about the kind of people aspect of some of these different tools. So if you're working with a lab, how do you get, your colleagues or the lab to maybe buy into using these? Are there opportunities, to do trainings together, that sort of thing? So I don't know if for any of the tools, Janet, that you just discussed, if you have recommendations or thoughts on that?
To be honest, I did see some discussion about that with some of the tools in the reviews, but I did not extract those out for this presentation, so I don't really have it at top of mind right now. But those are topics that are addressed if you do follow the links in that we have provided to some of the review consolidations there. People will talk about how easy it was or not so easy to get people up to speed as a group on using these tools. But definitely they all made the point that allow adequate time for training. Don't just throw a tool at your group and say, okay, now we're moving on, now we're gonna start using it right away, do allow for that time for training. That was pretty universal among the tools I saw.
And part of our goal today, I know we're kind of throwing a lot of tools out there. We're not looking in depth at any of them, but the goal is kind of to give you all some resources and just an idea of what the benefits of these different tools are. So you can see, a lot of times the question is, well, I don't know which tool my lab or group should, jump on board with. So kind of talking about, comparisons and the benefits and limitations of them to see for your particular situation. Maybe you'd want to look first at Basecamp versus Trello because you really need, that one feature, that kind of thing. So if y'all have questions about the features and any more detail about any of these, or you're curious, about diving deeper into kind of, one versus the other, if there's time, we can definitely address that at the end. And I apologize, I have to replace the batteries in my headphones because I can't hear as well with, and the battery just died. So give me one second, and then I will be right back to finish up the last sections.
Okay, so the next section, and Rachel's going to take it from here for a while to talk about the remaining tools. And the first section that she'll be talking about is tools that deal with file sharing and version control.
Okay. Yes, file sharing and version control. So as with Janet's sections, we're going to look at a couple of different tools in each of these categories and talk about, again, benefits and limitations. So the very first tool I want to spotlight for file sharing and version control is the Open Science Framework. So this is, and I want to kind of call out right away, not just for folks in science and engineering departments. It can be used by anyone. We in the library use it. It is a great open source general purpose project management platform, but we're putting it in this category primarily because it is really useful for when you're working on projects with a team, doing that file sharing. And you can do that both privately, and you can then share your project files publicly if you choose at any point to make your projects public online. So OSF does some really nice things for you and your team members as you're building out your project, tracking your project online. It does automatically track everyone's individual contributions. So this is really nice if you're working with lots of folks and you want to actually keep track of, who made a change when. This does that automatically. And the other huge selling point for me for this platform is that, a lot of times we have research materials and they live lots of different places. You might have some stuff in Google Drive. You might have some stuff in somebody else's institutional Dropbox or Box account, things like that. And what OSF allows you to do is go and integrate the file storage, systems and bring all of those materials, even if they live all over in different systems, you can kind of keep track of them in one place. It also automates the version control through things that you upload directly to your project in OSF. So there is built-in file storage, and you get, it's free and open source, so you don't need to pay. There is no paid version of this tool, but there is a cap on how much storage you can have for each project, and I believe for each account. But then you can link unlimited numbers of cloud storage integrations. So you can, have some stuff in OSF storage and then some stuff in RMail, Google Drive, whatever. And there are some built-in analytics tools that help you kind of track, if you make your project public, the impact of your research and who's looking at it, how often things are being accessed. Some of the limitations of this tool, and again, we're not kind of looking at all the different interfaces, but OSF has been criticized for having a little less intuitive interface to navigate. It can be kind of tricky, again, to kind of learn how to use it. And again, it does have that limited file storage if you're not linking to external services, but you can link to as many Dropbox or drives as you want. So GitHub is another platform that we're talking about within this umbrella of file sharing and version control. While it might be more frequently thought of as, a hosting platform for software and for collaborative software development, it can be used for other purposes. It's just simple file sharing. You can create private and public account or projects or repositories on GitHub. And something that I think a lot of folks don't know about is that you can use GitHub to host free websites from your GitHub repository. So that's called GitHub Pages, and it allows you to create really simple static websites. Maybe you just need to kind of, simple to deploy landing page for your, research project or lab or something like that. GitHub Pages might be a good option for you. So like OSF, it automatically tracks everyone's individual contributions to a project or repository. And again, what it was really designed for was automating version control, right? Being based on the version control language Git. And you can, again, host static websites using GitHub Pages. So while GitHub was built to host open source software, it is not itself open source, right? I believe it's currently owned by Microsoft. And some features, there is a paid version, right? A premium version or of account that you can, pay for. So certain features in terms of, I believe, currently collaborative projects, if you want to have a collaborative project, that has to be public. I might be misspeaking. I hope I'm not. So there are some features that are hidden behind that paywall. And GitHub in particular is not a recommended storage location if you want to file share sensitive data. In fact, most of the platforms we're talking about today are not going to be 100% compliant for all sorts of, restricted or sensitive data. So if that's something that you're working with and have questions about, we can address that if that's something you're dealing with. And then the very last tool within this file sharing, I'm not going to spend a lot of time on this because I believe Google Drive is familiar to a lot of folks. And it's primarily, we're mentioning it here as, a place to store and share and collaborate on stuff. As Janet talked about, the different Google apps that this integrates with and is kind of, part of the same suite. But primarily because here at UCR, RMail or Google Drive is the institutional storage solution that is supported here. So if you're a UCR community member with access to RMail, then you'll be able to use that for unlimited storage. And then you can integrate that with things like OSF or other, other platforms that allow you to integrate, cloud storage platforms. Google Drive is great for a little more granular control. So you can control those different levels, of like file sharing through links or directly with other people's accounts. You can do that at the, the file and the folder level. Shared drives get a little bit weirder, but that is a feature. Of course, it seamlessly integrates with those Google apps, and through the Google Drive app, you can access your files and do automated backups, which is another nice feature using the desktop and mobile app. Limitations, of course, Google wants you to kind of stay within its ecosystem. So it's really only built to play nice with other Google Suite programs. As Janet mentioned earlier, it does, most of the apps enable version control, and Drive itself does track versions of your folders and files, but it can be hard to go back and find specific versions. Whereas something like OSF and GitHub are really designed for that purpose, right? To enable you to really clearly track different versions and, manage conflicts when two people are editing a document at the same time. And just to throw out there, I always encourage folks to read the terms of service and privacy policies that these different companies have for their platforms. I would say Google falls on the not as friendly side in terms of their service and privacy policies, which are linked here if you'd like to read more. We also have information in the slides for example, if you're curious about what other folks at UCR are doing in these different platforms. So we've got a link here to OSF projects for researchers and projects and labs here at UCR. So that is in here. And we also have links to other resources for these particular file sharing tools. Are there any particular questions so far about this category of tool, or have you all used any of these or interested in learning more about them? Feel free to share that in the chat. But if not, I can also move on to our next tool section. And we are really breezing right through this. So we're going to have, it looks like, plenty of time to answer questions and maybe discuss and go back and kind of do some more comparison or poking around in the actual interfaces to any of the platforms that folks are particularly interested in. So the last group of tools we're going to look at is cloud-based programming and dependency management. So let me just define dependency management. I know different terms are used in different disciplines for this sort of thing, but when you're dealing with code and data, right, in different programming environments and programming languages, very often when you're working collaboratively, at least this is a problem I've seen a lot, is essentially what you want to avoid is you're creating code and you're working with data sets in a very specific environment on your computer or computers. I've seen a lot of folks, like emailing their R scripts or, Python scripts. And that's not going to be the best solution long term because there's lots of those little things about your environment, your operating system, the way your operating system treats file paths. You have particular versions of, your software or, for example, RStudio. You have different packages installed, maybe different versions of those packages. And all of those things, if they're not the same, when someone else goes to run your code, it can break it. It can just not run, right? So these are going to be tools that are going to either enable you to do cloud-based programming collaboratively with colleagues and students, or that will allow you to package your code and data to make it easier for others to rerun it. So a lot of the things we're going to talk about in this category enable research reproducibility. So to start with, because I'm a fan of R, and this is kind of just a shout out really, because I was really excited when RStudio came out with their cloud environment a couple of years ago. I think this is a fantastic way to teach because again, when I run workshops, for example, or, folks are running courses, it can be really tricky to manage those kinds of environments. If we have one student with a Mac with a different OS X on it that's not wanting to install that package, we get around that by having everyone run on a virtual server, in the cloud. Unfortunately, RStudio has recently changed their pricing policies. So there are some limitations now to using this tool that make it less appealing. And so we'll look at some alternatives. But essentially, this is a cloud-based programming environment, so you don't have to worry about your computer specs or operating system to run R on a virtual server. And this does allow you to collaborate on projects and code with other people. So the benefits to this, you can use the power of the R programming languages to analyze data, create visualizations, run R scripts in your browser. So maybe this is useful if you are, traveling or you're on a computer, you're across institutions, maybe less applicable right now in the pandemic. But, if you need a place to run R scripts without having something installed, this is an option. It lets you create, private projects, but you can also create projects in this system that then you can share the link to and people can hop on and work on your code. Limitations, obviously, this is, it only works for R. Maybe that's not actually obvious, so I should probably take the word obviously after this, but it is from RStudio, so it's an RStudio product. It requires an RStudio account, which is free to create, but, and here's the big kind of sticker why I don't really recommend this tool anymore. If you're using the free account, you only get 15 active working hours on the remote server per month. And that's not really a lot in the grand scheme of things for, kind of ongoing collaborative projects. It might work well still for a teaching, maybe if you, again, coming back to Lynn's question earlier, if you are needing to do trainings together or share code briefly, this could still be a good option. But we're gonna look at some other options that do allow you to use R and other kind of code-based work in the cloud. And perhaps the most well-known and robust version of this is Jupyter Notebooks. So part of the larger Jupyter project, which is, I believe, based at UC Berkeley. So this is an open source web app and way of sharing your code, visualizations, as well as narrative text together. So this is really frequently used as a teaching tool. So people will put together, and in fact, we're going to look at an example that is an online textbook that is written in Jupyter Notebooks so that students who are learning Python for the humanities can go through and click and kind of learn and have text and data and code all interspersed together in one document. So this is great for both reproducibility if you want to walk someone through your data processing and analysis workflows, but it's also, as I said, great for teaching programming languages. And the name Jupyter actually comes from the 3 programming languages it was originally designed for. So Julia, Python, and R, but now it actually runs on over 40 different programming languages, or you can, integrate code from 40 different programming languages in Jupyter Notebooks. It's great for creating and sharing documents with live code that others can run without needing to manage all those complex dependencies that we were talking about. And it's great, again, for research, reproducibility, replicability, enabling you to share your code and data. Some of the drawbacks of this, you have to kind of figure out where you're going to publish your notebooks. So there's lots of places people do share them. So something like GitHub or Bitbucket, you can, post your notebooks there in a repository. That's what a lot of folks do. And you do use Python, and you have to have an installed version of Python to create the notebooks to begin with. But I'm going to just show you very briefly what Jupyter Notebooks look like. So this is the landing page for an interactive online textbook, Python Programming for the Humanities. So if we just scroll and look at any of these chapters, the chapters themselves are Jupyter Notebooks. So they've got Python code blocks that are interactive, except this version here. So this is a Jupyter Notebook. It is being rendered and displayed by a tool called NB Viewer, Notebook Viewer, but it's not interactive. So that's where the next tool that we're going to look at comes in, and that is called Binder. So I'm actually going to, I'm going to click here because it takes a second to get things running. So I want to execute this code on Binder. And while this is running, I'm going to go back to my slides and talk about Binder. So Binder, I believe, is a project that first came online in about 2018. And this is a tool, again, open source, crowd-based, community-based, that allows you to turn a Git or GitHub repository into live interactive Jupyter Notebooks. As I said, a lot of folks will store their notebooks in GitHub. And what this does kind of in the back end, and we have a little snapshot of the interface here, you point it at a public repository, where your notebook lives, and then it's going to build a Docker image. So Docker is another tool that we're actually not going to look at in detail today, but what Docker does, and there's a couple of reasons for that if folks are interested. It's a proprietary tool. There's a lot of limitations in terms of running Jupyter Notebooks. This is a really straightforward option. So what it does is it goes and it builds a Docker image of your repository, including your code and your data, and you have to tell it what the dependencies are it's looking for, but then it's going to allow you to kind of easily manage those dependencies. So again, option for managing complex dependencies when you're sharing code and data without directly using a tool like Docker. It works, again, with many programming languages, anything that the Jupyter Notebooks, but it also works for things like RScripts, and it is open source and community supported, so it is free to use. Essentially, it's going to create a server for whatever notebooks you have, limitations being your notebooks or RScripts or whatever code it is that you want to run have to be hosted somewhere public so Binder can see them. And because it's this kind of community supported, shared virtual resource, the deployment of your repository, this is not going to be a good option if you have, really intense R, data analysis scripts that, you're pulling in so much data, it's going to need a lot of RAM. Your repository is going to be allocated just a max of 2 gigabytes of RAM, which is enough to do most, a lot of things, but not really kind of intense, computationally intensive things. So let's pop back over and look at our Binder instance for this Jupyter Notebook chapter. So it's giving me a notice here that it converted from an older version, but essentially this is a Jupyter Notebook being run. So it looks a little bit different. This is the live version, so you can make all kinds of changes to it. This is live code that's being run on a Python instance in the background. So I can actually write code here. So if we wanted to, this little quiz is asking us, calculate how many minutes there are in 7 weeks. So there are 60 minutes in an hour, 24 hours in a day, 7 days in a week, 7 weeks. And then we hit Control Enter on my operating system to print out. So that ran that command and returned something. So this is great for, again, reproducibility, having people run your code without having to, all right, make sure you've got this version installed and download this, these set of files and managing all those dependencies. So again, a great tool for that. And I believe, yes, we have time to talk about the last tool in this category, which is Renku. So Renku is, I'm mentioning it here at the end because it's a little bit more challenging to learn. It's a lot more intense, kind of industrial strength. It's a really fantastic, also open source project that is aimed at allowing you to make, to collaboratively work on projects and to make code and data, reproducible and shareable, and avoid a lot of those same issues with dependencies and things I was talking about. So it's kind of two different things. Renku is both an online, free to use and really robust platform. It's operated by the Swiss Data Center, I believe. And that's called Renku Lab. That's the one that lives online, and you log in, you have to create an account with them, and then you can create projects. It also has a command line interface. So it is, in my opinion, one of the best tools currently in development to manage, in particular, really complex collaborative data science pipelines and projects. It has a much steeper learning curve, right? So a lot of benefits. It's going to bundle a lot of things together. You can run a terminal in the cloud. You can run Python, run R scripts. It's got a lot of different things, including Git, that allow you to just do that all in the cloud versus having to have all those different tools installed on your computer. You can kind of package up in a similar way your code and data, but it does require familiarity with working at the command line and learning some new Renku commands. And it's more geared towards data scientists. It's not generally intended in the same way as something like Jupyter Notebooks and Binder to be a teaching tool, or kind of an easy starting point. Again, thinking back to how long is it going to take my lab or my group to train on this? So it has a steeper learning curve if you're not already familiar with Python, Git, Unix, those sorts of things. So for more information, I have some links here to documentation for these different platforms, as well as some tutorials. If you're curious about getting started with Jupyter Notebooks or Binder or Renku, they have a really great tutorial that is, again, linked here, and you can access these links on the slides at that URL. So in the last couple of minutes, Janet and I are, we've prepared some best practices for these different topics. So I will pass it back over to Janet to share some best practices in terms of kind of communicating with your colleagues as you do research remotely.
Right, so these points were just gathered from several articles that came out, especially right after the shutdown last spring, when we all sort of had to be working remotely all at once. And I think a lot of these are good points. Some of them seem common sense, but others that you might not have thought about. If you have a remote team going, it's best to have regularly scheduled check-ins. If you ever have doubt about whether I need to communicate with my team about this particular issue, go ahead and do it. It's always better to have that communication out there. I was surprised to find that researchers have found that conference calls without video are more effective for the team than having video calls. And I guess people pay more attention if they just have to listen or something like that. But sometimes, video calls are really necessary. And if you're having one with your team to go over input on a document, the best practice is to have your participants open the document outside of the video window rather than doing a screen share. And this allows for people participating to edit and scroll at their own pace. And it just makes for a better viewing experience overall. And if you are having a session where you all are looking at a document at the same time and making edits and comments and things, allow some time for that silent document review and actions. You don't have to have somebody talking all the time. It's okay to be silent for a while. And the last point is be sure to make time for informal interactions. And that can include celebrating, like when your project meets a particular interim goal or something like that, or somebody has a special event in their own lives. Do make time for that. It's really important to keep the group together, in just a more collaborative frame of mind. So that's what I found out about team communication. And now Rachel's going to fill you in on a few other aspects of best practices.
Yes, so we definitely wanted to kind of talk a bit about some of the best practices that apply to, file and data management and documentation, even though that's not a really exciting thing to talk about. It's so important for collaborative projects, right? So the number one thing, in terms of documentation and management is you're obviously going to want to have some kind of active backup strategy. So we recommend that you follow the 3-2-1 rule of data backup. And that means that you have at least 3 copies of your research files. You you have them stored on 2 different media, meaning, not everything is all on a hard drive. It might be on a hard drive. It might be also in the cloud. It might be also, on a server somewhere. So different media storage types. And then at least one of them's offsite. In the event of some catastrophic, physical event, say UCR was, there was some kind of tragedy that struck, like a fire or earthquake, that not all of your data is stored at UCR, on campus, in your office, or, something like that, in your dorm. So that the one offsite location, if it's in the cloud, also, make sure the cloud storage is also like not at your institution, but it's, some other location on the planet. So I'm not going to read through all these different questions for your active backup strategy. These are just some suggestions. So it's always great to think about this plan as you embark, with your colleagues, with your students, with your lab on a research project, to kind of think through this at the beginning, right? Rather than kind of reacting midway through, or, trying to figure out, oh, well, we're not backing up. And it's okay if you're at that point too, right? It's better to start doing this at any point than to not do it at all. But if you can, it's great to think through these questions at the beginning of a project, right? So who's going to be responsible for this? Where are things going to be stored? How are you going to be, tracking it? All of that. And then finally, in terms of making it easy for you and others to understand, what your data and files are, and how they're stored, just wanted to share some general best practices for kind of file naming and file organization, right? So generally recommend keeping 3 things in mind as you are deciding how you're organizing your research files and folders. And that's organization, context, and consistency. So by those, essentially thinking through what is going to be the most straightforward way for this project files or this project's files to be organized. So rather than having everything in just 1 or 2 folders, is there a way to kind of nest folders to have a logical hierarchy in place of different folders? Maybe you want to organize things by time. Maybe you want to organize things by sub phases of the project, or different people who are working on them. But whatever system you come up with, then context and consistency are really important. So context being, think about if your files were moved from one computer to another, or from one project folder to another, is there enough information in the folder and file names to know, okay, it's from this project that I worked on with that person that year, right? So think about including, I wouldn't have a folder called data, just that's bad, right? Because who knows what's in that data folder, even if it's nested, right? But if that data folder got copied and moved out of its project hierarchy, would you have enough context? And then just being consistent with whatever you go with. So again, probably don't need to read through all these different little file naming conventions, but essentially you want your files names to be both human and machine readable, right? So avoid things like spaces and special characters in your file names. Keep them short. You want to have some context, right? Maybe the name of the project, the name of the researcher, the type of file that it is, if it's raw data, process data, whatever. But generally keep them short. Definitely avoid generic file names. Again, that data file 1, data file 2, something like that. If those are moved, or you might have multiple projects that have the same generic file names, not a great idea. And it's recommended, to use version, kind of version numbers in your naming, so you can, kind of think ahead, use sequential numbering, and use numbers and maybe dashes and numbers to track major or minor versions of your different files. And yeah, we have another 4 more information slide here with some additional links and resources for you to explore in terms of communicating with your team while we're working remotely, and for kind of learning more about data management, file management, best practices, those sorts of things. So we have plenty of time at the end of the hour to answer any specific questions, or are there any tools that you would like us to go back to in particular? Are there any tools that you are excited to go and learn about now that maybe was new to you in this presentation? How well does our cloud work with these different tools? That's a great question. So for some of the tools, I tried to signal, this one has Google Drive integration. So by our cloud, do you mean our mail, like the Google Drive, or do you mean a different suite of tools? Is our cloud, is that the other ITS supported? Yes, so ITS, okay, yes, apologies. I'm newer to UCR, so I'm still remembering. I don't have the historical knowledge of all the different platforms. That's a great question. So our cloud, I actually don't know the answer to that question. Just frankly, Janet, do you have any idea in terms of our cloud?
No, I don't, sorry.
That's the older version. In fact, I can pop out of here. That's the older version of cloud storage that is supported by ITS here at UCR. There might be, I can track down if there's any resources on that ITS has provided for our cloud. Yeah, unfortunately, no, I don't. I'm sorry. Okay, other question, Google Drive files owned by, yes, that's a very, very important point. So that's why a backup strategy is really important, both for your personal files as well as your collaborative projects and professional materials, because I do not believe that employees or it might be different for some students, but I believe most UCR accounts will not be maintained after you leave the institution. So you'll want to make plans to back up or migrate your content out of Google Drive before you leave UCR. Oh, and then someone shared, Esra shared Overleaf. Overleaf is a great tool to collaborate on LaTeX documents, but the free version is limited. Yeah. Thank you for sharing that. That's, I'll take a look at that. I've heard of Overleaf, but I haven't used it. Are there other tools folks have used? Well, we wanted to share this link here. If at any point, you would like to reach out and get help using a particular tool, or you have research related questions, you can always go to the UCR Library website, to the Ask a Librarian, or follow the link that's on the screen here. If you're not certain, which librarian might be able to help with a particular question, you can use that link, or you can get in touch with us directly. We can share our emails and pop those in chat as well. So feel free to follow up if you have questions about any of these, or if there's particular tools you're really interested in, because folks have mentioned lab trainings, things like that. We're definitely interested in supporting different groups on campus using these tools. So if you have, for your department or a group of folks are interested in learning a tool, we might not be able to teach every single tool, but we were interested in hearing what your needs are. So if you, would like, if you're interested in trainings on these different tools, let us know. Thank you all. Another question, can ownership of Google Drive files be transferred? That's a great question as well. So the way that Google Drive, as I understand it, works is one person owns stuff. There is an owner, and this has been an issue for, so yes, I believe, yes, you can transfer the ownership of files, or people can create copies of files that they then own. But that can be an issue in shared drives, for example. I'm in a shared drive for research services in the library. If I create a file in that Google Drive, I'm the owner of that file. And it might work differently on different institutional accounts. But it is important to kind of know who owns the files in a shared drive. But yes, I believe it can be transferred. Janet, do you know anything more about that?
Again, sorry, I don't.
No, totally fine. Good questions. But if you're interested in, I'd be interested in hearing from folks if you are either wanting to migrate stuff out of our cloud or deciding on whether you should use move things to Google Drive to our mail. I'd be interested if that's something you're dealing with. But yes, want to be respectful of folks' time. So if you have to hop off, thank you all for joining us today. I hope that this was useful information. Again, you can go back and follow any of the links on the slides. But yeah, thank you. And we'll stick around for a few minutes too if folks have more questions. But I'm going to stop the recording now.